So we're working here today, again with our exponent laws. We're looking to review why our negative and why our zero exponent laws work as they work. This is a suitable video for you if you're in a 3C class or a 2D looking to review why these laws work. Prerequisite skills that I am assuming, if you are here, I'm assuming you're comfortable working with your powers. And I'm assuming that you're comfortable working with your three previous exponent laws. That is your multiplication of powers, your division of powers, and your power of a power law. Now let's jump right in. The first example, we're not going to use those previous exponent laws. We're going to just expand and cancel and see what happens. So let's work with our numerator here. We have a to the exponent 3 over a to the exponent 4. That's obviously division that's going on right here. A to the exponent 3 I know is a times a times a. A to the exponent 4 is a multiplied by itself 4 times. Now, if I am expanding here, any common factors that I see, well, a divided by a, that's just 1. A divided by a, that's 1. A divided by a, that's 1. And so what that leaves me with is simply 1 times 1 times 1, that's just 1, all divided by a. Those are my remaining pieces. That's what I'm working with right here, nice and easy. Now, I encourage you, pause the video here, try it out with your fraction here in part B. Go for it and see how you did. Good, so we recognize here we can cancel out 7 b's from the numerator and denominator. We're going to be left with simply 1 over b to the exponent 4. Fantastic. Well, that's all well and great. Let's double check. Does that work? Do we end up with a similar answer if we're working with 3 to the exponent 5 over 3? Now, in the denominator here, we know there's a hidden exponent on that. That's a 1. We're working with 3 times 3 times 3 times 3 times 3, all divided by 3. I know I can cancel out. I'm left with 3 to the exponent 4. This time, there is no fraction. If I were to put a fraction in here, it would be that hidden 1. I know if I'm dividing by 1, that doesn't accomplish anything, so I'm just working with 3 to the exponent 4. Now, if you followed there, great. We're looking at solving these exact same problems, but this time we're using our division of powers rule that we know how to use. So I encourage you, pause the video here. I want you to handle A, B, and C all together here, and then unpause and see how you did. Good, part A, nice and straightforward. We're working with a to the exponent 3 minus 4. We're subtracting these exponents because there's division going on. And 3 minus 4 is negative 1. So we'll need to be careful there. I need you to make sure you're nice and ready when you are subtracting two values. The order in which you subtract those values matters. And here we're left with a negative answer, negative 1. Over here, b to the exponent 7 minus 11. That is b to the exponent negative 4. And over here, 3 to the exponent 5 minus 1. If you're not sure where that 1 comes from, double check up here. And we're working with 3 to the exponent 4. Now, our observations actually lie only in parts A and B of this activity. Part C was an extra little piece to see what's happening. But in parts A and B, what we're seeing is depending on our strategy, we can either end up with 1 over a or with a to the exponent negative 1. And really the conclusion that I'm looking for us to come to right here is that these are exactly the same thing. These are equivalent. All right, these are two different ways of writing our powers. And often, and what we're going to prefer as we're working in this course, we're going to prefer to work with our powers with a positive power. Now, does that mean that you need to go through and write out your b's 18 times in order to see what cancels? No, absolutely not. What I'm hoping we'll be able to do is we'll be able to start with something like this. We'll be able to use shortcuts that we've already learned. In this case, that's our division of powers rule. And then we're going to know how to handle this negative power. We're going to be able to take this negative exponent and turn it into powers with a positive exponent. In this case, we're working with b to the exponent 7 over b to the exponent 11. We use our division of powers rule to come up with b to the exponent negative 4. And I'm hoping now we will be able to use our new pattern to turn that into 1 over b to the exponent 4. And I'm hoping that you can see this only works if our exponent ends up negative, right? If our exponent ends up positive, there's no need to do anything else. We can just work with 3 to the exponent 4. Now, what is this rule? What have we just observed is happening right here? Well, if I have anything, if I have any base, we'll say our base is b, to the exponent negative n. That is, if I have any negative base, I can turn that into 1 over b to the exponent positive n, where what we do is we just get rid of the negative on this exponent, we put it into a denominator, and we work with our numerator. Now, what you actually have not quite seen yet is this numerator. This comes from the numerator, or sorry, the denominator over here. All right, so sometimes we might end up with a different denominator. We'll see what happens as that works. That only works, as I said, that only works if we have a negative exponent that we're working with. Fantastic. Now, if that's the case, I want you to use this brand new rule. I want you to try out 1A, 1B, 1C, unpause the video, see how you did. Good. ABC, I'm hoping that you followed right along. Part D right here looks a little bit wonky. The base that we're working with is a fraction. We're working with a fractional base. That actually doesn't change anything right now. We still end up with 1 over 2 to the exponent 3. We've performed the exact same steps. But now, you know what? This still looks kind of complicated. So we know from our past experience with our fractions, that's just like 1 over 1 to the exponent 3 over 2 to the exponent 3. And what's really happening right here, I wish I had a little bit more space. Let's move over. What's really happening right here is this is 1 divided by 1 to the exponent 3 over 2 to the exponent 3. Well, when I'm dividing fractions, and here I'm dividing by a fraction, what I can do is I can change this first 1 into a fraction. How can I write 1 as a fraction? Oh, I just put it over 1, right? And then if I am dividing fractions, that's like multiplying by a reciprocal fraction or by a flipped over fraction. So that's like 1 over 1 times 2 to the exponent 3 over 1 to the exponent 3. Well, that's pretty straightforward. If I'm multiplying fractions, I just multiply across numerators and denominators, right? So 1 times 2 to the exponent 3, well, that's just 2 to the exponent 3, over 1 to the exponent 3. Fantastic. Well, 1 to the exponent 3, that's just 1, so that's like 2 to the exponent 3 over 1. Oh, wow, that's just like 2 to the exponent 3, and if I want to evaluate that further, I'm working with 8. A whole bunch of steps. Do you need to do these steps absolutely every single time? No, absolutely not. We're here for shortcuts. That's what we're looking for. 1 over 2 to the exponent negative 3, all to the exponent negative 3. Our shortcut that we can work with here, we can just flip this fraction and make the exponent positive. We're just working with 2 over 1 to the exponent positive 3. Fantastic. Well, 2 over 1, that's just like 2. So really, I'm working with 2 to the exponent 3. We know what we're doing there. That's 8. There's our shortcut. Now you have it for the future. So part D, what this really leads us into is the second part of our negative exponent law. If I'm working with a over b, if our base is a over b, if it's a fraction to a negative exponent, we'll call it negative n, that could be negative anything. If we're working to a negative exponent, what we can just do is flip our base, take the reciprocal base, and make our exponent positive. We know how to work with positive exponents with fractions. Nice work, nice and straightforward. Now let's take a look in example 3. We're going to head back to our tried and true strategy. We're going to expand and cancel our common factors, see what happens, and then we'll take our shortcuts that we know again to try and come up with a new law. I encourage you right here, I encourage you, pause the video, try, expand, cancel your common factors at the very least for part A, see what happens. We're moving ahead here. A to the exponent 4 is A times A times A times A. A to the exponent 4 is A times A times A times A. All right, so I'm working with A times itself 4 times over A times itself 4 times. I can cancel my common factors. 1, 1, 1, 1. Oh, so this is just equal to 1 times 1 times 1 times 1. That's just 1. Fantastic. From here, okay, we're working with 2 times x to the exponent 7 over 4 times x to the exponent 7. Well, that's like 2 times x times x times x times x times x times x times x, all divided by 4 times x times x times x times x times x times x times x. Oh my goodness, I'm glad that we're going to find ourselves a shortcut because I don't enjoy doing this. Well, that's all well and great. I can now cancel my common factors. Okay, so x and x cancel, that's 1. X divided by x is 1. Anything divided by itself is 1. I'm hoping you can see a pattern that's happening. Here, we're working with 2 times 1 times 1 times 1 times 1 times 1 over 4 times 1 times 1 times 1 times 1 times 1. We're just working with 2 over 4. Well, hang on. That means that the pieces we were working with at this x to the exponent 7, x to the exponent 7, they kind of canceled out. Okay. Well, if that's the case, let's go forward. Here, we're going to work with the exact same strategy. I want you to pause the video, try it out yourself. And even though I did not see the same exponents at the top, if you knew your exponent laws at this point, I'm sure you could have seen where this is heading, where everything cancels out. We're just working with a fraction that's equal to 1. Don't forget, if everything cancels out, your fraction's equal to 1, not 0. That's a common trap. I want you to make sure you're avoiding it. And lastly, before we make our conclusion, we're going to use our division of powers rule. And we might use our multiplication of powers when it comes up, but we're going to focus on our division of powers rule from our last lesson to write these following fractions as a single power. I encourage you to pause the video, check to see how you did. This is not a video lesson on this, so I want you to see what happens. Good, okay, pretty straightforward here, but you'll notice we have something funny going on. So we are subtracting our exponents. When we're subtracting these exponents, it is nice and straightforward. 4 minus 4, 4 minus 4 is 0, so we're working with a to the exponent 0. You might fall into a trap and say, hey, that's 0. Well, hang on, let's be careful. Right now, we just know it's a to the power of 0, a to the exponent 0. All right, well, when I was working with my x to the exponent 7, same thing. I end up with this funny exponent 0, same thing in part C with a 3. Now, let's go and compare what we know these are equal to from example, whoops, looks like my example numbers are off, and that's okay. Comparing example 3 and apparently our second example 2 right here. But either way, we're working with, we know this was equal to 1, and it turns out to look like a to the exponent 0. Okay, let's compare that over here. I know I'm working with 2 over 4, rather. And I end up with this second time when I'm using my division of powers rule, 2 times x to the exponent 0 over 4. And I'm working with either a 1 or a 3 to the exponent 0. Our conclusion, again, these are the same. These are two different ways of writing one thing. Anytime in the future you see anything to the exponent 0, that just equals 1. Okay, we've seen how it works using our division of powers rule. There are other ways at looking at, there are other strategies that we could have used to look at that. We just chose this one. That's all well and great. Our exponent rule then is a, that's a base of anything, to the exponent 0, just equals 1. Okay, now if I have something like here times a something to the exponent 0, then it's like that exponent 0 just kind of disappears, right? 2 times x to the exponent 0 over 4 is just like 2 times 1 over 4. All right, so it doesn't mean, just because you see an exponent 0 doesn't mean everything you're working with is equal to 1, but what it does mean is that the power you're working with is equal to 1. And in this case, the power that you're working with is just the x to the exponent 0. If you're confused by that terminology, go back and review your understanding of powers. All right, nice work right here. I want you to use this brand new strategy. I want you to try out 2A, 2B, 2C. Unpause the video, see how you did. Good, here's what we're working with. You can check your own work. If you followed along, I'm hoping you feel a little bit more comfortable with what you can do when you're working with an exponent that's a negative value or an exponent that's a 0. Nice work.